All right, folks, gather around, because today we're tackling a topic that's been floating around our conversations and our bloodstream for, well, far too long, with a whole lot of confusion. Cholesterol. You've definitely heard the terms good and bad, but have you ever really wondered what these tiny molecules are actually doing in your body and why they're so critical?
Right.
Is it really as simple as, just avoiding certain foods, or is there maybe a much deeper, more nuanced story to uncover here?
There definitely is.
Today, we're taking a deep dive into cholesterol. Our mission, should you choose to join us, is to unpack exactly what it is, why your body literally can't live without it, and how too much of the wrong kind can indeed spell trouble for your heart.
That's the plan.
But here's where we'll go beyond the headlines. We're also going to explore some of the latest science, stuff that's challenging some long-held beliefs, especially about what we call good cholesterol.
Yeah, that's a really interesting area right now.
And reveal that it's maybe not just about the numbers on your blood test result.
Yeah.
We'll discover why its functionality might matter far more than just its quantity, offering, hopefully, a truly fresh perspective on heart health.
Indeed. And our mission here is really to transform those sometimes confusing medical terms into clear, actionable insights.
Exactly.
We'll break down the science, maybe reveal some surprising facts, and definitely offer practical takeaways. We want you to feel empowered and well-informed, not overwhelmed, about taking charge of your heart health.
Right.
Because this isn't just a numbers game. It's really about understanding a complex system where every component has a vital and often surprising role.
Yeah.
Our goal is for you to walk away not just knowing more, but understanding why these things matter to your daily well-being.
Okay, sounds good. So let's start at the very beginning then. When we talk about cholesterol, what exactly are we referring to? What is this molecule, fundamentally?
Right. So at its core, cholesterol is the principal sterol, which is just a type of lipid or, a fat-like molecule, and it's found in every single animal cell. Every single one.
Wow, every cell.
Yeah, and it's not just a passive component. It's absolutely essential for animal life. You won't find it in things like bacteria, for instance.
Okay.
But in us and all other animals, our cells simply couldn't function without it. It's really a foundational building block.
That's a crucial point. It's vital for life, yet it gets demonized so often. It's almost universally talked about as if it's inherently bad. So what's the origin of that paradox? Why do we hear such conflicting messages about it?
That's a great question, and it really speaks to the complexity of biology, doesn't it? The term itself, cholesterol, actually has a fascinating origin.
Oh, yeah.
It comes from ancient Greek, chol meaning bile,
Okay.
and stereos meaning solid, plus the suffix ol, which just indicates an alcohol.
Bile solid.
Yeah, and it was first identified in solid form in gallstones way back in 1769, which kind of hints at its physical properties and its connection to the digestive system.
Interesting.
So the paradox lies in its dual nature. It's essential for life, absolutely, but in excess, or maybe in the wrong place, it's a contributor to disease. The demonization often stems from an oversimplification of its role, I think, focusing solely on its involvement in heart disease without appreciating its fundamental biological necessity.
Right. So it's less about cholesterol itself being inherently bad and more about how our body manages it. Or maybe mismanages it sometimes.
Exactly. It's all about balance and transport.
Okay, let's really dive into those essential roles you mentioned. What are some of the critical functions cholesterol performs that our bodies literally can't do without?
Absolutely. The list of its essential roles is pretty extensive and truly underscores its importance. Firstly, cholesterol is a critical structural component of all animal cell membranes. All of them.
Cell membranes,
Sure.
like the outer skin of the cell.
Precisely. Imagine your cells as tiny, flexible balloons. Cholesterol is sort of woven into the rubber, giving them stability and integrity.
Okay.
It's not just there. It's required to build and maintain these membranes, making sure they're strong enough to protect the cell, but also flexible enough to allow movement and interaction.
So it's not just floating around inside cells. It's literally part of the walls of every cell in your body.
Yeah.
Giving them shape and letting them function properly. That's quite a job.
It really is. It modulates membrane fluidity across different physiological temperatures, making sure our cells stay flexible enough to do their jobs, but also structured enough to maintain their integrity.
Right.
Think of it like the cell membrane's climate control and structural support system rolled into one. It prevents them from becoming too rigid or too leaky.
Oh, okay.
And this unique property is what allows animal cells to change shape And crucially, enables animals like us to move without needing rigid cell walls like plants have.
Right, plants are stuck.
Yeah. And furthermore, it significantly reduces the permeability of the plasma membrane to certain things like neutral solutes, hydrogen ions, sodium ions, basically helping to maintain a stable internal environment within each cell.
Okay, so structure is huge. But it doesn't stop there, right? Cholesterol isn't just structural, it's also a chemical precursor for a whole bunch of other vital substances, like a raw material.
That's absolutely right. It's a starting point for so many important molecules. One of its most well-known roles as a precursor is for the synthesis of vitamin D.
Ah, the sunshine vitamin.
Exactly, which is absolutely essential for calcium metabolism, bone health, immune function, you name it. Without cholesterol, our bodies couldn't even begin to make this vital vitamin from sunlight.
Wow.
And beyond that, it's the precursor for all steroid hormones.
All of them.
Yep, all of them. This includes the adrenal gland hormones like cortisol, which manages stress and inflammation, and aldosterone, which helps regulate blood pressure. And crucially, it's the building block for all our sex hormones, progesterone, estrogens, and testosterone, along with their derivatives. These are critical for reproduction, development, and just numerous other bodily functions. Imagine the impact if we couldn't produce those.
Yeah, no kidding. So from bone health to stress response to reproduction, cholesterol is right there at the very start of those crucial biochemical chains. What about its role in, say, our nervous system? That seems important too.
That's an excellent question. And yes, it's another area where cholesterol is absolutely indispensable. It's deeply involved in cell signaling and vitally nerve health.
Yeah, so
Well, it assists in forming what are called lipid rafts within the plasma membrane. These are like tiny specialized platforms that bring receptor proteins close to crucial second messenger molecules,
okay.
which enables really effective and rapid cell communication. But what's truly fascinating, and perhaps less commonly known, is its crucial role in the formation of the myelin sheath around our nerve fibers.
The myelin sheath, that sounds important. Can you explain what that is and why cholesterol is so vital for it?
Absolutely. Think of your nerve fibers like electrical wires.
Okay.
For those wires to transmit signals quickly and efficiently, they need insulation, right?
Right, like the plastic coating.
Exactly. The myelin sheath provides that insulation for nerves. And it's remarkably rich in cholesterol. Its formation ensures electrical impulses can travel rapidly along your nerves. This allows for quick muscle movements, fast thinking, all the intricate functions of your nervous system.
Wow.
Without sufficient cholesterol, this insulation can actually break down.
Wow, so cholesterol is actually critical for nerve insulation.
Yeah.
I never connected it to something like multiple sclerosis before, where demyelination, the loss of that myelin sheath, is a key part of the disease.
Precisely.
That really brings home how fundamental cholesterol is for brain and nervous system function, way beyond just heart health.
It really is. The integrity of the myelin sheath is paramount, and cholesterol is a primary component. And there's more. Cholesterol also binds to and affects the gating of several ion channels, like the nicotinic acetylcholine receptor, which are crucial for nerve impulses. It even activates something called the estrogen-related receptor alpha, suggesting cholesterol might be an endogenous ligand, meaning it naturally binds to and activates this receptor, influencing gene expression. Its reach is truly profound.
And it contributes to our outer defenses too, right? Our skin.
Yes, absolutely. It's a key component of the epidermal barrier. That's the outermost protective layer of your skin.
Okay.
In the stratum corneum, the very surface layer, cholesterol works together with other lipids like ceramides and free fatty acids to form a really robust water-impermeable barrier.
So it keeps water in.
Exactly. This barrier is crucial for preventing evaporative water loss, which is vital for maintaining skin integrity, keeping harmful substances out, and ensuring you stay properly hydrated. It's like the waterproof siding on your house, basically.
Protecting everything inside. Okay. So it's doing everything from building our cells and making hormones to insulating our nerves and protecting our skin. And you also mentioned it helps with something called substrate presentation. What's that quickly?
Yeah, briefly, in cell membranes, cholesterol helps regulate biological processes where certain enzymes, like one called phospholipase D2, need to access specific molecules in the membrane to get activated. It's almost like cholesterol is helping position other molecules correctly so those enzymes can do their work effectively.
Gotcha.
So as you can see, cholesterol isn't just a single-purpose molecule. It's a multi-talented, absolutely essential player in countless bodily functions.
Right.
So the first big insight here really is cholesterol isn't inherently bad. It's a fundamental building block. The problem isn't its existence, but its management and transport in the body.
That makes so much sense. Okay, so if cholesterol is so vital in doing all these jobs, how does it actually move around our bodies? I imagine it can't just like dissolve and free float in our watery blood, right? Oil and water.
You're absolutely right. Exactly. Given cholesterol's minimal solubility in water, think of oil and water not mixing it. Can't simply float freely through your bloodstream like, say, glucose can.
Right.
It needs a sophisticated transport system, a fleet of specialized delivery trucks, if you will, to carry it safely through the watery highways of your circulatory system.
And those delivery trucks are called lipoproteins, correct?
Yeah.
These complex little particles. They have water-soluble exteriors, so they travel okay through blood, and then lipid-soluble interiors, where they stash the cholesterol. They basically emulsify it.
That's it precisely. A very clever design. Among these lipoproteins, one often gets the bad rap. Low-density lipoprotein, or LDL.
The bad cholesterol.
Often labeled that way, yes. It's responsible for carrying the majority of cholesterol in your blood, delivering it from the liver out to cells throughout the body that need it.
And why is it labeled bad? Because when there's too much of it floating around, this LDL cholesterol can start to build up in the walls of your arteries, forming what we call plaque. My analogy here is always thinking of arteries like old water pipes. If you pour too much sticky grease down them, it starts to line the pipes, right? With LDL, it seems like a similar idea. It just starts sticking and piling up.
That's a very apt analogy. That plaque buildup is a condition known as atherosclerosis.
Right.
It progressively narrows the arteries, makes them harder, more brittle, and restricts that vital blood flow to your organs and tissues.
And the consequences can be pretty severe.
They can. An increased risk for heart attack, stroke, and peripheral artery disease, or PAD. What's particularly concerning is when LDL becomes oxidized, damaged by free radicals.
Oxidized LDL.
Yes. This oxidized LDL is then readily taken up by specialized immune cells called macrophages. These macrophages become what are called foam cells.
Foam cells.
Yeah, they get bloated with this oxidized fat, and they get trapped in the vessel walls, further fueling plaque formation and inflammation. So the key isn't just that LDL exists, it's that excessive LDL, especially when it's oxidized, becomes the dangerous factor.
Okay, but hold on. It's not all bad news in the transport department. We've also got our cleanup crew, right? High-density lipoprotein, or HDL. This is our good cholesterol.
That's right.
And having a healthy level of it really seems to help protect you against heart disease and stroke.
Precisely. HDL works by initiating a crucial process called reverse cholesterol transport, or RCT.
Reverse transport. Sounds good.
It is. It effectively carries excess cholesterol away from your arteries and tissues and brings it back to the liver.
Oh, okay.
Once there, the liver processes it for breakdown and eventual excretion from the body. It's an essential part of the body's waste management system for cholesterol, almost like a recycling service.
So, sticking with the pipe analogy,
Yeah.
if LDL is the sticky grease lining your pipes, HDL is like a high-speed vacuum cleaner, sucking up that excess grease from the pipes and taking it to the recycling plant, the liver. It's keeping those arteries clear.
That's a good way to visualize it.
But it's important to remember a key nuance here, isn't it? We're going to dive much deeper into this later, but what's the quick insight about HDL?
It is important. While HDL is undoubtedly beneficial, and yes, high levels generally correlate with better health outcomes, suggesting a protective role, it only carries a fraction of the total blood cholesterol. It doesn't, eliminate all the LDL. And here's a sneak peek into that deep dive insight we'll explore later. The functionality of HDL, what it actually does, is proving to be even more critical than just the amount circulating.
Functionality over quantity.
Exactly. Simply having more HDL doesn't automatically mean better protection. This really challenges a long-held belief, and it's a crucial distinction for understanding your heart health properly.
Okay, can't wait to get into that. Now, besides LDL and HDL, there's another important player in this whole lipid story. Triglycerides. What are they?
Right, triglycerides. These are actually the most common type of fat in your body. Their main job is to store excess energy from your diet.
So like energy reserves.
Exactly. Think of them as your body's energy savings account, tucked away for when you need them later. If you consume more calories than you burn, especially from carbohydrates and fats, your body converts those extra calories into triglycerides and stores them in fat cells.
So if you're eating a lot of foods high in fat and sugar, or just consistently eating more calories than your body needs right then, your body is intelligently saving that energy for later. Smart. But like anything, too much of a good thing can cause trouble, right? How do high triglycerides impact our heart?
That's right. High triglyceride levels, especially when they're combined with high LDL or low HDL cholesterol, also contribute significantly to those fatty buildups in artery walls atherosclerosis.
Okay.
This increases your risk for heart attack and stroke. They are definitely a clear marker of metabolic health or sometimes lack thereof.
So what are the levels we should aim for?
For adults, a healthy triglyceride level is typically below 150 milligrams per deciliter or mgdl.
Okay, under 150.
Yeah. Levels between 150 and 199 milligdl are considered borderline high. 200 to 499 milligdl are classified as high, and anything above 500 milligdl is considered very high.
Wow, very high. What happens then?
Well, very high levels can even lead to serious acute issues like acute pancreatitis, which is a sudden and painful inflammation of the pancreas. So keeping them in check is important.
Got it. So besides our main players, LDL, HDL, and triglycerides, are there any other lipoproteins worth a quick mention in this complex transport system, just briefly?
Briefly, yes. We also have chylomicrons. These are very large lipoproteins that primarily carry dietary fats from your intestine to your body cells right after you eat a meal.
Okay, post-meal delivery.
Exactly. Then there's VLDL, or very low-density lipoprotein. This one's produced by your liver, and its main job is transporting triglycerides that the liver makes out to your tissues.
Okay.
And finally, there's IDL, or intermediate density lipoprotein. It's kind of a transitional particle. It forms as VLDL sheds its triglycerides, and eventually it becomes LDL.
This is part of the life cycle.
Exactly. Each plays its part in this intricate delivery and recycling system, making sure all the different fats get where they need to go. It really highlights the body's highly organized approach to fat metabolism.
Okay, so moving from transport to production, let's explore where cholesterol actually comes from. Our bodies don't just absorb all of it, they actively create it, right? So where is our internal cholesterol factory located?
It's quite a marvel of biochemical engineering, really. Almost all animal tissues have the capacity to synthesize cholesterol from a very simple precursor molecule called acetyl-CoA.
Acetyl-CoA, okay.
But your liver and your intestines are particularly prolific. They are the main factories producing about 80% of your daily cholesterol needs.
80%, that's huge. So most of the cholesterol in our bodies is homemade, essentially.
For the most part, yes. The remaining 20% typically comes from dietary sources, what we eat.
And it's not some simple process, right? You mentioned it's like a 37-step operation.
Indeed. It's a complex multi-step pathway. A key part of this intricate process is called the mevalonate pathway. And within that pathway, there's a specific enzyme called HMG-CoA reductase. This enzyme serves as the rate-limiting step.
Rate-limiting, meaning it controls the speed of the whole process.
Exactly. It sets the pace. And this is a critical detail because this enzyme, HMG-CoA reductase, is the primary target for statin drugs.
The cholesterol-lowering medications.
Correct. Statins are a class of medication widely used to lower cholesterol. By inhibiting HMG-CoA reductase, statins effectively slow down the body's internal cholesterol production.
Clever.
The importance of this whole pathway was actually recognized with the Nobel Prize in Physiology or Medicine back in 1964. It was shared by Konrad Bloch and Fyodor Lenin for their groundbreaking discoveries concerning the mechanisms and regulation of cholesterol and fatty acid metabolism.
Wow, a Nobel Prize for cholesterol synthesis. That really underscores how significant this metabolic process is.
It absolutely does.
And speaking of regulation, you mentioned the body doesn't just produce cholesterol constantly. It's got a pretty sophisticated system for keeping things in balance, doesn't it? A feedback loop.
Absolutely. Your body employs a very sophisticated feedback loop to regulate cholesterol synthesis. Essentially, if your dietary intake of cholesterol or certain fats is higher, your body's internal production tends to decrease, and vice versa.
So it adjusts based on input.
Exactly. It's a finely tuned homeostatic mechanism designed to maintain optimal levels without overproducing or underproducing.
So your body's got its own internal thermostat for cholesterol production. That's pretty clever. Can you tell us a bit more about how that thermostat works at a cellular level? What's sensing the levels?
Yeah, a big part of that thermostat involves something called the SREBP pathway. That stands for Sterol Regulatory Element Binding Protein.
SREBP.
This protein, it lives in a part of the cell called the endoplasmic reticulum, and it acts like a sophisticated sensor, constantly monitoring the cholesterol levels within the cell.
Okay.
If those cholesterol levels fall too low, SREBP springs into action. It actually moves from the ER to the cell's nucleus. And once there, it activates specific specific genes. These include the genes for the LDL receptor, the very receptor that pulls LDL cholesterol out of the bloodstream into the cell.
Ah, bringing more in.
Exactly. And it also activates the gene for HMG-CoA reductase, the enzyme we just talked about, boosting internal production.
So it ramps up both uptake and production when levels are low.
Precisely. It ensures your cells have the cholesterol they need while also helping to regulate what's circulating in the blood.
This intricate pathway sounds like a brilliant piece of biological engineering. It even won a Nobel Prize too, right?
It truly is brilliant. And yes, this pathway was largely figured out by Michael S. Brown and Joseph L. Goldstein back in the 1970s, which led to their Nobel Prize in 1985.
Ah.
Their work showed how this SREBP pathway controls the expression of many genes governing not just cholesterol, but lipid formation, overall metabolism, and even how your body allocates its fuel sources. It's really a foundational understanding of metabolic regulation that's had profound implications for medicine.
Amazing.
And one more clever regulatory trick. Cholesterol synthesis also halts if cellular ATP, your body's main energy currency, drops to low levels.
Oh, so if the cell's low on energy, it stops making cholesterol.
Yeah, it conserves vital resources when energy is scarce. No point building stuff if you don't have the power.
Talk about efficient resource management. Okay, so the body makes it, regulates it. But what happens to cholesterol once it's done its job, or if there's an excess? It doesn't just disappear, does it? Does it get recycled?
Not at all. Cholesterol is constantly recycled within the body. The liver plays the central role here. It processes cholesterol and excretes it into bile, or biliary fluids.
Okay, into bile.
Right, which are then stored in the gallbladder before being released into the digestive tract to help with digestion. Now, interestingly, about 50% of this cholesterol that's excreted into the bile is then reabsorbed by the small intestine and returned to the bloodstream.
Half of it gets reabsorbed. Wow.
Yeah, it maintains a continuous cycle. It's quite efficient.
And a good portion of that cholesterol in bile gets converted or oxidized into various bile acids, right? Which are crucial for.
Absolutely crucial for digesting and absorbing the dietary fats you eat. So it's performing a double duty in the gut. It's being recycled, and it's actively helping you break down and absorb fats from your food efficiently.
But there's a potential downside to it being in bile, isn't there? Gallstones.
Yes, that's the main one. Under certain circumstances, if cholesterol becomes too concentrated in the bile, particularly within the gallbladder, it can crystallize. It precipitates out of solution and forms solid stones. And these cholesterol-based gallstones are, in fact, the major component of most gallstones people develop.
Okay. Good to know. Any other ways it gets eliminated?
Well, on a less problematic but interesting note, every day up to about a gram of cholesterol enters the colon. Down there, the colonic bacteria metabolize it into a compound called coprostanol.
Coprostanol?
Yeah, it's a non-absorbable sterol, meaning your body can't take it back up. And this coprostanol is then excreted in feces. So that's another route for elimination mediated by our gut microbes.
Fascinating. The gut bacteria get involved too. Now, here's another twist in this cholesterol story that always intrigues me. The cholesterol in your brain. Is that connected to the cholesterol we've been discussing in the blood and liver? Does dietary cholesterol affect brain cholesterol?
That's a really perceptive question, and the answer is generally no, not directly. Brain cholesterol is quite distinct.
Really? How so?
It's functionally separate from peripheral cholesterol. What I mean is the cholesterol you get from your diet or what's produced in your liver and circulating in your blood doesn't effectively cross the blood-brain barrier.
The barrier keeps it out.
For the most part, yes. Instead, specialized brain cells called astrocytes are responsible for producing and distributing cholesterol locally right there within the brain itself.
So the brain makes its own supply.
Exactly. This ensures the central nervous system has its own dedicated, tightly regulated supply for its unique and critical functions, like that myelin sheath formation we talked about, completely independent of your circulating blood levels.
That is fascinating. A separate cholesterol economy just for the brain. Okay, let's shift gears now and turn our attention to what many people think of first when they hear the word cholesterol. What we eat.
Yes, diet.
This is where it gets truly interesting for a lot of folks, and it's definitely a spot where many long-held beliefs have seen some pretty big shifts in recent years. We're talking about dietary cholesterol, the cholesterol you actually consume in food, and how it really affects your blood levels.
Right. To start, it's important to understand the main sources of cholesterol in our diets, since all animal cells synthesize cholesterol for their own needs.
Because they need it to.
Exactly. So all animal-based foods naturally contain it, though, in varying amounts. This includes things like red meat, egg yolks and whole eggs, liver, kidney, other organ meats like giblets, fish oil, shellfish, and butter.
So basically anything from an animal.
Pretty much. Even human breast milk contains significant quantities, which really highlights its natural presence in animal nutrition right from the start of life.
Right. And on the flip side of that coin, plant foods generally contain very, very small amounts of cholesterol, if any at all, correct?
Correct. Plants don't really use or make cholesterol in the same way animals do.
But plants do offer something else that's relevant here, something called phytosterols. They're chemically similar. How do those interact with the cholesterol we eat?
Phytosterols are quite clever, actually. They are structurally similar enough to cholesterol that they effectively compete with it for absorption in your intestines.
They compete, so they block cholesterol absorption.
To some extent, yes. This competition means that when you consume phytosterols, they can reduce the absorption of both the cholesterol you ate and the cholesterol that your liver excreted into bile that was heading for reabsorption.
So it reduces the recycling too.
Potentially, yes. And this can lead to lower circulating cholesterol levels overall. You can find these beneficial phytosterols naturally in foods like avocado, flax seeds, peanuts, and other nuts and seeds. Plus, they're often added to functional foods like certain margarines or yogurts, or available as supplements specifically designed to help manage cholesterol.
Interesting. Okay, this brings us right to the heart of the matter for many people. The impact of dietary cholesterol, the cholesterol in food, on your blood cholesterol levels. This topic has seen some significant reevaluation over the years. For so long, we were told to strictly limit dietary cholesterol, especially things like eggs. What's the latest understanding here?
This is really a prime example of how scientific understanding evolves, isn't it? For years, decades even, the prevailing advice was definitely to avoid dietary cholesterol, almost like it was a poison, particularly targeting foods like egg yolks.
Oh yeah, I remember the egg white omelet craze.
Exactly. But the science has indeed become much more nuanced. The link isn't as direct or as strong for most people as we once thought.
That's a real shift in thinking for many people who grew up with those strict dietary warnings. So, what is the updated take on how the cholesterol in our food actually impacts the cholesterol in our blood?
Well, what's fascinating here is that most of the cholesterol we ingest from food is actually poorly absorbed by the gut anyway. Your body isn't super efficient at taking it up.
Really? Only fraction gets in?
For many people, yes. And perhaps even more critically, your body has that internal compensation mechanism. We talked about that feedback loop.
Right, the thermostat.
Exactly. When you eat more cholesterol, your body often responds by simply reducing its own synthesis to help maintain balance.
So it makes less if you eat more.
Generally, yes. This finely tuned regulation means that for most people, the amount of cholesterol they eat has a relatively small impact on their blood cholesterol levels compared to other dietary factors, like the types of fat they eat. There was even a study in rats years ago that showed an inverse correlation. The more cholesterol the rats ate, the lower their blood cholesterol became. Now, of course, that's rats, not humans. But it does highlight the body's sophisticated regulatory capacity.
So the key takeaway here, and this is often misunderstood, is that for most people, it's not the cholesterol in the food itself that's the biggest driver for raising blood cholesterol levels. That really challenges decades of conventional dietary wisdom.
It really does.
So, if it's not primarily the dietary cholesterol directly, then what is the main dietary culprit for raising, say, LDL, the bad cholesterol?
Precisely. The problem, as current science strongly suggests, is that foods high in cholesterol, often not always, but often also contain high amounts of saturated fats and or trans fats.
The company it keeps.
Exactly. And these types of fats are what significantly raise your LDL, or bad cholesterol numbers, much more reliably than dietary cholesterol itself does for most people. So it's often less about the cholesterol in the egg yolk and maybe more about the bacon and butter cooked with it, or the highly processed foods where trans fats used to hide more often. It's really about the overall dietary pattern and the types of fat consumed.
That distinction is a potential game changer for how people approach their diet. And the official medical guidelines have started to catch up with this evolving understanding, haven't they? How have they changed?
They have indeed. If you look back, say, to 2015, the U.S. dietary guidelines made a significant shift. They moved away from recommending a rigid 300 milligram a day upper limit for dietary cholesterol.
Right, I remember that number.
To instead recommending to eat as little dietary cholesterol as possible. Now, this wasn't exactly a free pass to eat unlimited amounts.
Right.
But it acknowledged the association between generally lower dietary cholesterol intake and reduced cardiovascular disease risk within a broader healthy eating pattern, while also recognizing the body's compensatory mechanisms and the greater impact of saturated and trans fats.
Okay, a subtle but important shift. And what about organizations like the American Heart Association? What's their stance?
Building on that, the American Heart Association and the American College of Cardiology, in their 2013 guidelines, recommended focusing primarily on healthy dietary patterns, rather than fixating on rigid, specific numerical limits for dietary cholesterol.
Patterns over numbers?
Exactly. Their reasoning was that comprehensive dietary patterns, like the DAH dietary approaches to stop hypertension, and the Mediterranean diet, which are naturally lower in cholesterol, saturated fat, and sodium, and higher in fiber and beneficial fats. Well, these patterns are much easier for people to actually implement and sustain long-term than meticulously counting milligrams of cholesterol every day.
Makes sense. Easier to follow a whole way of eating.
And these patterns have proven benefits for heart health overall.
So it's about the whole picture of what you're eating rather than zeroing in on just one nutrient. What about specific recommendations for the types of fats we should be eating?
Right. The AHA went a step further in guidance around 2017, specifically recommending that people actively switch out saturated fats again, found mainly in red meat, full-fat dairy, tropical oils for polyunsaturated fats, like those found in vegetable oils, nuts, seeds, and fish. This swap is known to actively reduce cardiovascular disease risk. It reinforces the idea that the type of fat you're eating generally matters more for blood cholesterol than the amount of cholesterol in the food itself.
Okay, replace saturated with polyunsaturated. Got it.
Okay.
And what about those phytosterols we mentioned earlier? Are there recommendations for supplementing with those?
Yes, for individuals looking for an extra helping hand in managing their cholesterol, particularly LDL, dietary guidelines do suggest specific doses for phytosterol supplements or fortified foods. The recommendation is typically around 1.6 to 3.0 grams per day.
And how effective are they at those doses? Do they actually work?
They do seem to have a measurable effect. Meta-analyses, which combine data from multiple studies, have shown that consuming phytosterols in that recommended range can reduce LDL cholesterol by approximately 12% on average.
12%, that's pretty significant.
It can be, yes. It offers a scientifically supported dietary strategy to help manage cholesterol levels, usually in addition to, not instead of, broader healthy dietary patterns and other lifestyle changes. It's another tool in the toolbox.
Okay, that's really helpful context on the dietary side. Now, let's turn our attention to what I often call knowing your numbers. Understanding your own body's cholesterol levels through testing.
Absolutely crucial.
This is so critical because, and this is truly unsettling for many people, most individuals with high cholesterol feel absolutely nothing. It's often completely silent.
That's the danger.
There are usually no warning signs, no aches or pains, no bells or whistles, often until you're suddenly hit with a serious event like a heart attack or a stroke.
That silence is precisely why regular testing is so vitally important. For the vast majority of people, the only reliable way to detect high cholesterol is through a simple blood test. Now, occasionally, some individuals, usually with very high levels, might develop yellowish skin growths called xanthomas.
Xanthomas.
Yes, they're cholesterol-rich deposits. They can appear around the eyes or on tendons, like the Achilles tendon. But these are relatively rare indicators and usually point to significantly elevated cholesterol levels, often with a genetic component. You can't rely on seeing those.
Right. So if there are usually no symptoms, when should people start getting these numbers checked? And how often should they do it?
Good question. The general recommendations from groups like the American Heart Association are that adults aged 20 and older should get their cholesterol tested every 4 to 6 years as a baseline.
Okay, starting at 20.
Yes. However, this frequency often needs to increase with age and depending on individual risk factors. For instance, for males between the ages of 45 and 65 and females between 55 and 65, testing every 1 to 2 years is often recommended.
More frequent then?
Yes. And for seniors over 65, it's typically advised to get checked annually.
Annually for seniors. Okay, what about kids?
Children should generally have their first cholesterol test between the ages of 9 and 11, and then possibly again every 5 years or so.
Yeah.
However, earlier and more frequent testing is definitely recommended if there's a strong family history of high cholesterol or early heart disease, or if the child has other conditions like obesity or diabetes.
Right, family history is key.
Absolutely. And of course, more frequent testing is also advised for any adult who already has known risk factors like diabetes, high blood pressure, a personal or strong family history of coronary artery disease, or if they're currently taking statin medications to manage their cholesterol. Your doctor tailors the frequency.
Okay. And what exactly are they checking when you get that blood drawn? What's the actual test called?
Your healthcare provider will order what's called a lipid panel, or sometimes a lipid profile. It's a straightforward blood test.
And you usually have to fast for that, right?
Typically, yes. It usually requires fasting for about 9 to 12 hours beforehand. This is mainly because eating can temporarily elevate your triglyceride levels, so fasting gives a more accurate baseline reading, especially for triglycerides and calculated LDL.
Makes sense. And what does the panel measure?
The standard lipid panel measures 4 key components: your total cholesterol, your HDL cholesterol, the good kind, your LDL cholesterol, the bad kind, and your triglycerides.
Okay, the big 4.
Exactly. And the results are typically expressed in milligrams per deciliter, or mgdl, in the United States.
And here's the simple takeaway to remember when you're looking at those results, right? Generally speaking, you want your LDL to be low and your HDL to be high.
That's the basic principle, yes. Keep the bad low and the good high.
Can you break down what those desirable numbers generally look like for adults? Let's start with total cholesterol.
Sure. For total cholesterol, a desirable level is generally considered to be below 200 milligdl.
Under 200.
Right. Between 200 and 239 milligdl is classified as borderline high, and anything 240 milligdl or above is considered high risk.
Okay. And for LDL cholesterol, the bad stuff, what are the ranges we should be aware of? Where do we want that number?
For LDL, the optimal or desirable level is generally below 100 milligdl.
Under 100.
Yes. And really, for many people, particularly those at higher risk, lower is often considered better. There isn't really a widely recognized lower limit where it becomes dangerous. Near optimal is considered 100 to 129 milligdl. Borderline high is 130 to 159 milligdl. High is 160 to 189 milligdl. And very high is anything above 190 milligdl.
Okay.
Now, it's really important to note, though, that if you have established heart disease, diabetes, or multiple other risk factors, your healthcare provider may set a much lower LDL target for you, perhaps even below 70 milligdl.
Wow, below 70. That's quite low.
It is. It's a more aggressive target aimed at significantly reducing the risk of future cardiovascular events in those high-risk individuals. So the ideal number really depends on your overall health profile.
Right, personalized. Okay, what about HDL, the good cholesterol? We want that one to be high, correct?
Yes, for HDL cholesterol, generally higher is better. For males, a level of 40 milligdl or higher is considered protective. For females, the threshold is a bit higher, typically 50 milligdl or higher.
Why the difference between men and women?
Hormonal differences, mainly estrogen in premenopausal women, tend to keep HDL levels naturally higher.
Okay.
Ideally, though, for both sexes, an HDL level above 60 milligdl is considered optimal and offers significant protection against heart disease. And unlike LDL, there isn't really an upper limit for HDL that's routinely considered dangerous in isolation, although we'll get into the nuances of very high HDL later.
With the functionality piece. Okay. And finally, triglycerides. What's the healthy range there?
For triglycerides, as we mentioned earlier, healthy levels are considered below 150 milligdl. Anything consistently above that warrants discussion with your doctor about potential causes and management strategies.
Got it. Now, sometimes these numbers aren't just a reflection of lifestyle choices like diet and exercise. There can be a powerful genetic component involved, something you're simply born with that makes managing cholesterol much tougher.
Absolutely. Genetics can play a huge role for some individuals. A significant condition here is familial hypercholesterolemia, or FH.
FH, what is that exactly?
FH is an inherited genetic disorder. It's caused by mutations, most commonly in the gene for the LDL receptor, the very receptor responsible for clearing LDL cholesterol from the blood. About 1 in 250 people worldwide have a mutation causing FH.
1 in 250, that's more common than I would have thought.
It is relatively common for a genetic disorder, yes.
And what does having FH mean for someone's health?
It means their body can't remove LDL cholesterol effectively from their blood. This causes very high LDL levels, often 2 to 4 times higher than normal, right from birth.
Wow, from birth?
Yes. And this dramatically increases their risk of developing premature heart disease, having a heart attack or a stroke at a much younger age than the general population, often in their 30s, 40s, or even earlier if it's left untreated.
That's incredibly serious.
It is. Early diagnosis through screening, especially if there's a family history, and aggressive lifelong management, usually involving medication like statins from a young age, are absolutely crucial for people with FH.
Are there other genetic conditions that affect cholesterol?
Yes, there are other less common genetic mutations, for instance, in the PCSK9 gene or the gene for apolipoprotein B, a component of LDL, that can also cause inherited forms of high cholesterol. It really emphasizes that for some people, high cholesterol isn't primarily about lifestyle. It's deeply rooted in their genetic makeup, underscoring the critical need for medical evaluation and intervention in those cases.
That's a really important point. Genetics matter. Okay, if you've been listening closely, you know that understanding your cholesterol numbers is a big first step. But here's the really empowering truth, I think. You're often not just stuck with the cholesterol numbers you have.
That's right.
For many, many people, achieving good, healthy levels is possible through making smart, healthy choices. You really do have a lot of agency here.
That's a crucial point to emphasize. Lifestyle changes are incredibly powerful. They often serve as the very first line of defense against high cholesterol, and sometimes they're all that's needed.
So where do we start? Diet seems like a big one.
Absolutely. Let's dive into dietary choices, because what you put on your plate can make a significant difference. Firstly, actively reducing your intake of saturated fats is key for lowering LDL.
And where do we find those mainly?
Primarily in red meat, especially fatty cuts, processed meats like sausage and bacon, full-fat dairy products like butter, cream, and cheese, and also some tropical oils like coconut oil and palm oil, which are often found in processed foods. Swapping these out for healthier fats can directly help decrease your LDL, that bad cholesterol.
Okay, less saturated fat. What about trans fats? We hear a lot about those.
Trans fats are definitely ones to avoid completely if possible. Historically, these were often found in things like stick margarines, commercially baked goods, cookies, cakes, pastries, fried foods, and shortening.
The partially hydrogenated oils.
Exactly, those artificial trans fats created through partial hydrogenation. The good news is the FDA effectively banned these artificial trans fats in the U.S. food supply, with compliance required by early 2021.
Oh, so they should be gone, mostly.
Mostly, yes. But it's still wise to check labels, especially on older products or imported foods, and be aware that small amounts of naturally occurring trans fats exist in meat and dairy. The main message is, artificial trans fats raise LDL and also lower HDL, making them particularly bad news for heart health. Avoid them.
Got it. Avoid trans fats. What should we eat more of?
Increasing your intake of soluble fiber is very beneficial.
Soluble fiber. Like in?
Found in foods like oatmeal, oat bran, barley, beans and lentils, Brussels sprouts, apples, pears, citrus fruits. Soluble fiber can significantly reduce the absorption of cholesterol into your bloodstream because it forms a gel in your digestive tract and binds to cholesterol and bile acids, helping to carry them out of the body.
So it physically removes cholesterol. Clever.
It is. Also, incorporating foods rich in omega-3 fatty acids is a great idea.
Fish oil stuff.
Often associated with fish oil, yes. Found in fatty fish like salmon, mackerel, herring, sardines, as well as plant sources like walnuts, flax seeds, and chia seeds. While omega-3s don't typically lower LDL directly, they offer other significant heart-healthy benefits like potentially reducing blood pressure, lowering triglycerides, and reducing inflammation.
Good for overall heart health then. Anything else on the food front?
One more thing sometimes mentioned is whey protein, which is a component of dairy products and also available as a supplement. Some studies have suggested that whey protein intake might help lower LDL, total cholesterol, and even blood pressure, though more research is ongoing.
Okay.
But really, the overarching advice is to focus on those established, heart-healthy dietary patterns we mentioned earlier, like the DSH diet or the Mediterranean diet. They naturally incorporate all these beneficial elements. Low saturated trans fat, high fiber, healthy fats, lots of fruits, vegetables, whole grains. It's a comprehensive and sustainable approach.
Makes sense. Focus on the pattern. Now, beyond what you eat, it's absolutely about how you move. You got to get active every day if you want to keep that heart and your cholesterol levels happy.
Indeed. Regular physical activity is incredibly important. Moderate physical activity is particularly effective at helping to raise your HDL, the good cholesterol.
Oh, exercise boosts the good stuff.
It can, yes. And it also helps improve overall blood lipid profiles, manage weight, lower blood pressure, and reduce inflammation. It's a win-win-win.
So how much activity are we realistically talking about? Do I need to run a marathon?
Not at all. Consistency is much more important than intensity for most people. The general recommendation is to aim for at least 150 minutes of moderate intensity aerobic activity per week.
150 minutes?
Yeah.
So it's like 30 minutes 5 times a week.
Exactly. Or if you prefer more vigorous activity like jogging or swimming laps, you could aim for 75 minutes per week, maybe 20-25 minutes, 3 times a week. Muscle strengthening activities are also recommended at least twice a week.
And moderate intensity means?
Yeah.
What? Like you can talk but not sing?
That's a great way to put it. Yeah, brisk walking, cycling on level ground, gardening, dancing, activities where your heart rate is elevated, you're breathing a bit harder, but you can still carry on a conversation.
Okay, practical tip here. You don't need to join a fancy gym or buy expensive gear, right? Just take a brisk daily walk, maybe during your lunch break, or walk the dog with a bit more purpose.
Absolutely.
If you can, maybe bike to work or for errands, or simply make a habit of choosing the stairs instead of the elevator whenever possible. Make movement a natural part of your daily rhythm. Even small bursts of activity throughout the day add up.
They really do. Every little bit helps.
Okay, next lifestyle change. This one's huge. Quit smoking and all tobacco products.
Absolutely critical. Perhaps one of the single most impactful things you can do for your cardiovascular health.
How does smoking affect cholesterol and heart health?
Smoking causes direct damage to your blood vessel walls, making them stiffer and more prone to plaque buildup. It accelerates the hardening of the arteries, atherosclerosis, lowers your HDL cholesterol levels significantly, and increases the tendency for blood to clot. It's just incredibly damaging across the board for your heart and circulation.
Yikes. But the good news is the benefits of quitting start almost immediately, right?
They do, and they are truly remarkable. Within just 20 minutes of quitting, your blood pressure and heart rate start to decrease towards normal levels.
20 minutes?
Yeah, within just 3 months, your blood circulation and lung function begin to improve noticeably. And within 1 year of quitting, your excess risk of coronary heart disease is cut in half compared to someone who continues to smoke.
Wow, cut in half within a year. That's a powerful and pretty immediate incentive for anyone thinking about quitting.
Absolutely. It's never too late, and the benefits start right away.
Okay, another big one. Lose weight if you're carrying extra pounds.
Yeah.
Even a modest amount of weight loss can make a difference, right?
Yes, definitely. Even losing just 5 to 10% of your body weight, if you're overweight or obese, can significantly improve your cholesterol levels.
How does excess weight impact cholesterol?
Excess body fat, particularly visceral fat stored around the abdomen, tends to increase LDL and triglyceride levels while lowering HDL levels. So shedding some of those extra pounds can really help shift those numbers in a healthier direction.
And again, small changes can add up here too, right? You don't need a crash diet.
Absolutely not. Small, sustainable changes are key. For instance, switching out sugary beverages like soda or juice for water can save a surprising number of calories. Instead of reaching for high-calorie snacks like chips or cookies, maybe grab some air-popped popcorn, a piece of fruit, or a handful of nuts. Look for opportunities to incorporate more activity into your daily routine. Even simple things like standing up while talking on the phone, taking stretch breaks, or doing some light gardening or housework. Every little bit contributes.
Makes sense. Okay, what about alcohol? We sometimes hear conflicting things. A little glass of red wine is sometimes touted as heart healthy. How does alcohol fit into the cholesterol picture?
Right, the alcohol question.
Yeah.
It's complex. Alcohol in moderation has been linked in some observational studies to modestly higher HDL cholesterol levels.
Ah, so it might raise the good cholesterol.
It might, yes. However, the evidence isn't strong enough, and the potential risks associated with alcohol often outweigh this potential minor benefit. Medical experts generally do not recommend that individuals who don't currently drink start consuming alcohol just for potential heart benefits.
Okay, don't start drinking for your heart. But if you do drink...
If you do choose to drink, moderation is absolutely key. That's generally defined as up to 1 drink per day for women of all ages and for men older than 65, and up to 2 drinks per day for men aged 65 and younger.
1 or 2 drinks max. And a drink is?
A standard drink is typically defined as 12 ounces of regular beer, 5 ounces of wine, or 1.5 ounces of distilled spirits, like whiskey or vodka.
Got it. And exceeding those limits is bad news.
Definitely. Excessive alcohol consumption can lead to a host of serious health problems, including high blood pressure, heart failure, stroke, liver disease, certain cancers, and addiction. These risks far outweigh any potential minor HDL benefits. It's really important to be mindful of those limits and discuss alcohol use honestly with your doctor.
Okay, moderation is key, if at all. Now, 2 more quick but potentially mighty tips for a healthy heart and maybe cholesterol levels that often get overlooked. Manage your stress and get quality sleep. How do these connect?
They connect quite significantly, actually, though perhaps indirectly. Chronic stress, the kind that goes on day after day, can influence hormone levels like cortisol.
The stress hormone.
Exactly. And elevated cortisol over long periods can, in turn, affect cholesterol production, triglyceride levels, blood pressure, and even lead to behaviors like stress eating unhealthy foods or reduced physical activity, all of which impact heart health.
Okay, so stress has knock-on effects. What about sleep?
Similarly, poor or insufficient sleep can disrupt metabolic processes throughout the body. There's growing evidence linking poor sleep quality and duration to increased risk of obesity, diabetes, high blood pressure, and cardiovascular disease, potentially through effects on hormones, inflammation, and appetite regulation.
So we need to chill out and sleep well.
Pretty much. Prioritizing stress reduction techniques that work for you, whether it's meditation, deep breathing exercises, yoga, spending time in nature, pursuing hobbies alongside ensuring you get roughly 7 to 9 hours of quality sleep per night. These are really vital for overall cardiovascular health and can indirectly support healthier cholesterol levels and better heart function. They aren't just nice-to-haves, they're fundamental pillars of your body's regulatory systems.
Excellent advice. Okay, now, while these lifestyle changes are incredibly powerful and should always be the foundation, sometimes they aren't quite enough on their own to bring cholesterol levels into a healthy range. This can be especially true for individuals with genetic predispositions like FHR, or those who already have established heart disease or other conditions like diabetes. In such cases, your healthcare team may recommend specific medications.
That's absolutely right. Lifestyle is paramount, but medications are crucial tools when lifestyle changes alone aren't sufficient to reach target cholesterol levels or adequately reduce cardiovascular risk.
And those common type of medication people usually hear about are statins, right?
Yes, statins are by far the most common and generally the most effective class of medications for lowering LDL cholesterol.
How do they work again? We touched on this earlier.
They work primarily by inhibiting that key enzyme in the liver, HMG-CoA reductase, which we discussed in the context of cholesterol synthesis.
Right, they slow down the factory.
Exactly. By reducing the liver's production of cholesterol, statins prompt the liver to take up more LDL cholesterol from the bloodstream, thereby lowering circulating LDL levels quite significantly.
How significant are we talking?
It varies depending on the specific statin and the dose, but they can lower LDL by anywhere from 20% to over 55%. And numerous large-scale studies have shown that this LDL reduction directly translates into reduced risk. For example, research suggests that for every 40 mLDL reduction in LDL achieved with statins, the risk of major cardiovascular events like heart attack and stroke can be reduced by about 20-25%.
Wow, that's a substantial risk reduction.
It is. Statins also appear to have other beneficial effects beyond just LDL lowering, like potentially reducing inflammation in the arteries and helping to stabilize existing plaque, making it less likely to rupture and cause a clot.
So they're not just lowering numbers on a page, they're actively working to protect your arteries in multiple ways. When are they typically prescribed? Is it just for super high numbers?
Not necessarily just for high numbers anymore. Statins are often recommended and sometimes strongly necessary for individuals with conditions like familial hypercholesterolemia, FH, anyone who has already had a heart attack or stroke, that's called secondary prevention, people with diabetes, especially over age 40, and individuals deemed to be at high risk for future cardiovascular events based on risk assessment tools that consider multiple factors like age, blood pressure, smoking status, and cholesterol levels.
So even if your cholesterol numbers seem okay by older standards, if your overall risk is high, a statin might still be recommended.
Correct. The guidelines have shifted towards treating overall cardiovascular risk, not just a specific cholesterol number in isolation. So it's really an individualized decision made between you and your doctor based on a comprehensive risk assessment.
Okay. Are there other types of cholesterol medications besides statins?
Yes, there are other options, often used either in combination with statins if LDL goals aren't met, or sometimes if someone can't tolerate statins. These include drugs like ezetimibe, which works differently by inhibiting the absorption of cholesterol from the intestine.
So it blocks uptake from food and bile.
Exactly. There are also PCSK9 inhibitors, which are powerful injectable drugs usually reserved for very high-risk patients or those with FH who need additional LDL lowering. For high triglycerides, doctors might prescribe fibrates or concentrated omega-3 fatty acids, prescription-strength fish oil.
So there's a range of tools available.
Yes, there are several classes of drugs that target different aspects of lipid metabolism.
The bottom line here, folks, seems to be always have an open, honest conversation with your healthcare team about the best treatment plan for you. They're your best guides on this journey to heart health, considering your individual numbers, risk factors, and preferences.
Absolutely. Shared decision-making is key.
Okay, let's unpack this next part because it feels like we're really getting into the cutting edge now. For decades, we've been fed a pretty simple message. The higher your HDL, the better.
Right. That's been the standard thinking.
We've seen HDL as the undisputed hero, the good guy, sweeping in to clean up the arteries. But recent evidence from both genetic studies and large clinical trials is actually challenging that long-standing, maybe overly simplistic notion. It seems it's time to truly refine our understanding of HDL because it's not quite as straightforward as we once thought.
That's absolutely right. What's really fascinating here, and a bit counterintuitive based on the old thinking, is that just having higher HDL-C levels, the amount of cholesterol carried by HDL particles, isn't invariably beneficial in every single case.
Not always better. How so?
Well, for example, some genetic variants have been discovered that lead to a modest, lifelong increase in a person's HDL-C levels. But, intriguingly, having these genetic variants doesn't actually seem to correspond with a lower risk of cardiovascular disease.
Huh. So their HDL number is higher, but their heart risk isn't lower.
Exactly. That suggests that simply having more HDL particles floating around or more cholesterol packed into them isn't the whole story. It really points towards the idea that the quality or the function of the HDL is paramount, perhaps more so than just the quantity.
And here's a real head-turner of a finding that seems to have really solidified this new perspective.
Yeah.
There's a rare genetic mutation called the ApoII-Milana mutation. What happens with that?
Right. The ApoII-Milana story is remarkable. ApoII is the main protein component of HDL. This specific mutation actually leads to very low levels of both ApoII and HDL-C in the people who carry it.
Very low HDL, so they should be at high risk.
According to the old higher is always better model, yes. But here's the kicker. These carriers, despite having very low HDL, show no signs of premature coronary artery disease. In fact, they seem to be protected.
Wow. That's astounding. It directly contradicts the simple belief. What does this tell us then?
This provides really strong clinical support for the idea that the functionality of HDL, what it actually does in terms of transporting cholesterol out of cells, reducing inflammation, acting as an antioxidant, is far more important for cardiovascular protection than just the circulating level of HDL-C that we measure on a standard blood test.
So it's not just about the total number of members in the cleanup crew, but how effectively each member is actually performing their job.
That's a perfect analogy. It truly highlights the need to look beyond that single HDL-C number on the report.
And that analogy works because HDL isn't just one single uniform thing, is it? It's actually a diverse collection.
Exactly. HDL is highly heterogeneous. It's actually a complex group of particles that differ significantly in their density, their size, and their precise protein and lipid composition. You have small, dense HDL, large, buoyant HDL, particles with different proteins attached.
A whole zoo of HDL particles.
Pretty much. And because of this vast diversity, each subtype might have slightly different biological activities. You simply can't infer its complex overall functionality, its ability to protect your arteries from just measuring the total amount of cholesterol, HDL-C, carried by all these different particles combined. You might have a lot of HDL particles, but if they're not the right kind or if they're not working properly, then that high number might not mean much.
Right. Function over form or quantity. And we know HDL's main job is that reverse cholesterol transport, clearing cholesterol out.
Yeah.
But you mentioned it has other benefits too.
Yes, absolutely. Its benefits extend far beyond just its primary role in RCT, bringing cholesterol back to the liver. HDL possesses a multitude of other crucial biological properties that likely contribute to its protective effect against cardiovascular disease.
Like what?
These include potent antioxidative functions. It can neutralize damaging free radicals that injure blood vessel walls. It has significant anti-inflammatory effects, helping to calm down harmful inflammation within the arteries, which is a key driver of atherosclerosis.
Okay, antioxidant and anti-inflammatory.
Plus, it has beneficial endothelial and vasodilatory functions, meaning it helps keep the lining of your blood vessels, the endothelium, healthy and functional, partly by increasing the production of nitric oxide, a molecule that helps blood vessels relax and widen, improving blood flow.
So it helps blood vessels relax.
Yes. Furthermore, it appears to have antithrombotic properties, meaning it might help prevent the formation of dangerous blood clots. And it exhibits cytoprotective functions, shielding various cells from damage or death. It's really a multi-talented protective agent when it's working correctly.
A real workhorse.
Yeah.
Now here's where it gets truly intriguing and maybe a bit worrying. Even good cholesterol, our hero HDL, can sometimes go rogue, can't it? Even the best protective systems can be compromised or even turn harmful if the conditions are right. What can cause HDL to become less functional or even detrimental?
Precisely. HDL isn't always the good guy under all circumstances. For instance, some research suggests that cholesterol-overloaded HDL particles might become functionally abnormal and could actually have a negative pro-atherogenic impact.
Overloaded, like they're carrying too much cholesterol.
Potentially, yes. In some large population studies, surprisingly, very high HDL-C levels, say greater than 70 or 80 milli-GDL, and the presence of very large HDL particles have been associated with a higher cardiovascular disease risk, not lower.
Higher risk with very high HDL. That seems completely backward.
It does. Based on the old model, it suggests there might be a saturation point, or that perhaps these overly large or overloaded particles become dysfunctional, less efficient at removing cholesterol, or maybe even promote inflammation under certain conditions. The U-shaped curve phenomenon?
A U-shaped curve.
Yeah.
Meaning too low is bad, but too high might also be bad.
Exactly. For HDL, it seems optimal might be in a high normal range, not necessarily the higher the absolute better.
Fascinating. Okay, so being overloaded can be bad. What else can impair its function? You mentioned inflammation earlier.
Yes. Another critical aspect is what's known as the acute phase response. During times of significant physiological stress, like a major infection, surgery, trauma, or even chronic inflammatory conditions like rheumatoid arthritis,
Okay.
the body undergoes a systemic inflammatory response. In this altered state, the composition and function of HDL can dramatically change. It can actually convert from being primarily anti-inflammatory to becoming pro-inflammatory.
Wow, it switches sides. How?
Proteins associated with inflammation like serum amyloid A, SAA, dramatically increase in the blood and bind extensively to HDL particles. This displaces some of the normal beneficial proteins like ApoAI, altering the particle's function. This acute phase HDL loses many of its protective abilities and can even contribute to vascular damage. So your HDL's function isn't static. It can change significantly based on your body's overall inflammatory state.
That's a profound insight. HDL function depends on the body's context. And I imagine chemical modifications like damage to the HDL particle itself can also turn it against you.
Correct. Various chemical modifications can impair HDL function. Processes like oxidation, damage from free radicals, glycation, where sugar molecules attach to proteins common in diabetes with high blood sugar, and carbamylation, related to kidney dysfunction. All of these can chemically alter the proteins and lipids within HDL particles.
Like rust forming on the machinery.
That's a good analogy. These modifications can render HDL dysfunctional, significantly impairing its protective actions, like its ability to promote cholesterol efflux or act as an antioxidant. It becomes less effective or potentially even harmful.
And it's not just internal chemistry like diabetes or kidney disease. Our lifestyle choices and other conditions also play a big role in altering HDL functionality, don't they?
Absolutely. Obesity, for example, is often associated with lower HDL levels, but also with impaired HDL function, even independent of the level. Metabolic syndrome, that cluster of conditions including high blood pressure, high blood sugar, unhealthy cholesterol levels, and excess abdominal fat, is particularly linked to dysfunctional HDL. It often leads to the formation of small, dense HDL particles that don't work as well.
Yeah.
Even ethnicity can play a role, potentially interacting with lifestyle factors. For instance, some studies in Black South African women found they had improved HDL antioxidant functionality compared to white women, despite having higher rates of obesity and lower HDL-C levels, suggesting complex interactions.
It's interesting.
And crucially, dietary habits matter directly for HDL function. Diets high in saturated fat seem to impair HDL's anti-inflammatory potential, while consuming more polyunsaturated fats appears to improve it. It truly goes to show just how many factors genetics, disease states, lifestyle, diet influence, not just how much HDL you have, but how well this tiny yet mighty particle actually works.
This complexity really underscores why simply looking at that HDL-C number on a standard lab report might not be giving us the full, accurate picture of someone's risk or protection level. So if HDL-C isn't the best measure, what is a more accurate way to assess HDL's true value or functionality? Is there a better test?
This brings us to a key metric that researchers are increasingly focusing on to assess HDL's true protective value: cholesterol efflux capacity, often abbreviated as CEC.
Cholesterol efflux capacity, CEC. Okay. What does that measure?
Unlike HDL-C, which just measures the amount of cholesterol carried by HDL, CEC is a functional assay. It directly measures the ability of a person's HDL particles in their blood serum to remove excess cholesterol from cells, specifically from macrophages, those immune cells that become foam cells in the artery wall.
So it measures how well HDL actually does its cleanup job.
Exactly. It quantifies the first crucial step in reverse cholesterol transport, getting cholesterol out of those potentially problematic cells in the artery lining. This process is thought to be highly relevant for atheroprotection, the prevention of plaque buildup.
And how does the CEC measure correlate with heart disease risk compared to just the HDL-C number?
And here's the real kicker. Multiple studies have now shown a strong inverse association between CEC and cardiovascular disease risk, meaning higher efflux capacity is linked to lower risk.
Okay, that makes sense. Higher function, lower risk.
Yes. But importantly, this association holds true even after adjusting for HDL-C levels.
Independent of the HDL number.
Yes. This means someone could have normal or even high HDL-C numbers on their blood test. But if their CEC, their HDL function is poor, they might still be at a significantly higher risk for heart disease. Conversely, someone might have lower HDL-C but good CEC and potentially be better protected. It truly highlights how a functional measure like CEC can give us a much clearer, more accurate, and potentially more predictive picture of risk than the simple HDL-C level alone.
That's huge. It really suggests we should be measuring function, not just quantity.
Yeah.
Are there conditions where CEC is known to be impaired?
Indeed. Research has shown that CEC is often impaired in individuals with chronic kidney disease, metabolic syndrome, type 2 diabetes mellitus, and various autoimmune inflammatory disorders like rheumatoid arthritis or lupus.
Okay.
Even factors like male sex and being a current smoker are associated with decreased CEC. Understanding these factors and how they impact HDL function opens entirely new avenues for developing treatments that go beyond simply trying to raise HDL-C levels, which has largely been unsuccessful in clinical trials.
Right, focusing on quality over quantity. And that leads us nicely into some exciting future therapeutic directions. It sounds like scientists are now working on new agents and therapies specifically designed to enhance this cholesterol efflux capacity, CEC, and improved HDL functionality rather than just trying to artificially boost HDL-C numbers. Can you give us a glimpse of what's being explored?
Yes, the focus is definitely shifting towards enhancing function. Some approaches involve infusions of components that mimic or boost functional HDL. For example, clinical trials have explored infusions of recombinant ApoAI Milano, like a drug called MDCO216, or plasma-derived ApoAI, like CSL112.
Infusing the key protein.
Essentially, yes. The idea is to directly provide functional HDL building blocks or particles to promote cholesterol efflux from artery walls and potentially even cause regression or shrinking of existing atherosclerosis. Early results have been mixed but promising in some aspects.
Interesting.
There's also active research into small molecules that could boost the body's own production of ApoAI or enhance the function of existing HDL particles. And looking further ahead, gene therapy is being explored as a potential long-term strategy. The idea would be to introduce genetic material that could permanently enhance HDL functionality from within, essentially reprogramming the body to produce more effective HDL particles throughout life.
Wow, gene therapy for HDL function. That sounds very futuristic.
It's still early days for gene therapy in this area, but it represents the kind of targeted, sophisticated development that's happening now. The goal is a more effective approach to heart health, truly focusing on the quality and function, not just the quantity, of this vital cholesterol transport system.
Okay, this has been incredibly illuminating. So let's try to wrap this up. What does this all mean for us, having explored all these fascinating, sometimes complex aspects of cholesterol?
Well, I think
It seems clear that cholesterol isn't just a simple villain or hero, right? It's a complex, absolutely essential molecule that plays many, many vital roles in your body.
exactly. It's indispensable.
Understanding the different types, LDL, HDL, triglycerides, how your body makes and manages them, and especially this critical importance of HDL functionality over just its quantity. That really empowers you, I think, to take a more informed and proactive approach to your own heart health. It's definitely not just about that single total cholesterol number or even just the LDL and HDL numbers on a lab report anymore. There's a deeper, more nuanced understanding required.
That's absolutely the key takeaway. Don't just live in the numbers alone. Yes, get your cholesterol tested regularly. That's vital for screening. But then discuss your full lipid profile, all its components, and what they mean in the context of your overall risk with your healthcare provider.
Right.
And critically, focus relentlessly on those comprehensive lifestyle changes. That means prioritizing a heart-healthy diet, Rich in fiber, fruits, vegetables, healthy unsaturated fats, low in saturated and trans fats. It means getting regular physical activity, quitting smoking and all tobacco use, and maintaining a healthy weight.
Because those actions support not just healthy levels.
Exactly. They support truly functional cholesterol, helping ensure those HDL molecules are doing their protective job effectively and keeping LDL in check. And then, when lifestyle isn't enough, or if your risk is inherently high due to genetics or other conditions, embrace medical treatments as prescribed by your healthcare team. Understand that those medications are there to support your body's intricate systems and actively protect your long-term health.
Well said. Your heart's been beating faithfully for you since day one. Maybe it really is time you truly understood how to give it the VIP treatment it deserves. And that treatment goes beyond just the numbers. It involves focusing on the quality and the function of every molecule working within it, like that crucial HDL. It makes you wonder, what new discoveries will further refine our understanding of this tiny yet mighty lipid in the coming years? And how will that knowledge empower us to live even healthier, longer lives? Something to think about. Thank you so much for joining us on this deep dive today.
My pleasure. It's a fascinating topic.